For those of you who were here last week, you'll recall that I made a claim about Agile, which is that Agile is this negotiation, this working agreement between business and between development. And business promises to provide kind of immediate access to expertise and information, and development promises to deliver features at a steady pace, deliver frequently, and deliver the highest priority based on the product owner or what business deems like the most valuable. So be very responsive to change. Now, this can break down in two ways. If business underestimates what it means to provide information, and they don't provide sufficient access to expertise, that's one way it can break down. You frequently see that in the applying Agile to the enterprise world. And then the other way it can break down is if the development team does not actually have sufficient skill or technologies to be able to execute in a sustainable manner. So let's assume that the team does not actually have sufficient skill. What does that look like? If you, let's zoom into this picture here. So this picture here, it's a little bit askew, but the horizontal axis is showing over time, and the vertical axis is showing value. Okay, so ideally, this black line that you see here, okay, that just like a straight 45-degree angle, that's kind of ideal. What we would like is, as time passes, we're able to create value with our product or our application. But what's actually kind of typical is the ability to create value over time kind of slows down. And what happens is, if you get into a situation where you can't actually increase value, so any attempt to change your code or your product, any attempt to add a feature or fix a bug, reintroduces another bug. So essentially 100% of your development is dominated by failure demand. And that's called a design dead core. So the core of your application is design dead. It means it's not amenable to change. And that's actually inevitable for pretty much every single application. After 5 years, without careful kind of attention, if people are just focused on delivery, that's where all applications kind of end up. Now, Ops Core, which is our core product, is much older than that and is not design dead. So we've done something. We've done something to kind of escape this kind of pattern. So how do you escape this? So before we go on to this, I want to just talk about a couple other ways to think about this. So one way to think about this is that as a software developer and being on the development team, you actually have two responsibilities. And these will never be stated to you explicitly. They won't be stated to you explicitly outside of the team or by management or by business, because these are two games that not everyone's aware of, okay? But you are playing them constantly as a software developer. And the two games are this. One is you have to figure out how to actually deliver and meet the commitments for whatever your timeline and your current commitments are. So that might be your current iteration, or it may be your current release. Maybe a monthly milestone or a 3-month milestone, or it may just be a 2-week milestone or a 1-week milestone. But whatever your current focus is, you have to deliver on that, on your commitment, and you have to set up for success for the next iteration. Okay, so no one will ever tell you that's your job. This might be the first time you're hearing about this, but you're actually responsible for both of these things. And if you sacrifice the second game for the first, the business will fail, the product will fail in the long term, and not even that long, okay? It can happen very rapidly, okay? So So you are the ones who understand this, and you actually own this responsibility. So anytime a business says, oh, like, look, don't worry about the technical debt, that's not their responsibility. That's your responsibility. Okay. And anytime they say, oh, just make it happen, like we got to go faster, they're not actually asking you to sacrifice the long-term well-being of the business. Okay. You still have to use your judgment, and you have to actually preserve the health of the application. Okay. So the other thing I want to share is that maintenance is programming. So if you think maintenance is something different from development, like, oh, there's a maintenance team or maintenance programmers, and programming is basically kind of this creative act where you get to create brand new stuff, and people who kind of like clean things up, that's like a different category of work or a different team. That's like, I want to dismiss that kind of perspective, right? So maintenance is programming. You will be continually like maintaining code. If you're not interested in maintenance programming, like you're either not interested in programming, you're not interested in programming here, or this is just not the right environment. Maybe there's like other places where you can just create a knockoff like app, and there's no consequences. Like it's just a throwaway app. But that's not what we build here. We build products, and we don't build them for the short term. We're not building them for like a 1 month and then kind of, throw it away or neglect it. So maintenance is programming. Now that's like the challenge of software development. And I haven't yet told you how to escape this pattern of like design dead core. So how do you escape this? How you escape this is quite simply kind of test-driven development. So let's kind of zoom into this picture here. So Malcolm Gladwell has kind of popularized this idea that mastery is 10,000 hours. So you can see this horizontal axis is time, and 10K, this is my 10,000 hours, that's mastery. And this vertical axis is showing 100% at the top, and it's showing how many people kind of continue on this path towards mastery. And what you might think is like, oh, this dashed line is kind of the reality of the situation. And this is not true just for test-driven development. You can pick any kind of non-trivial skill, right? Playing music, playing the violin, piano, learning how to juggle, driving, doing like racing, performance driving. So any non-trivial skill does not actually proceed along this path. Okay. You don't lose like 50% of the people at the 5,000 mark, 5,000 hour mark, right? You actually lose like 99% of the people before they ever get to the first 100 hours, right? And that's very true of test-driven development, more so than probably a lot of other skills, because the first 100 hours, like the things that are told to you in terms of here's how you do test-driven development. You write a test, you run it, you see that it's read, and then you write the simplest possible thing to get it to pass. And then after that, you refactor. It's fantastic, and it's completely insufficient for people to do test-driven development. What happens is if you learn that, you go to work and you start applying it on your day-to-day work. And if you have legacy code, definition of legacy code is just code without tests. That code is not amenable to testing. And so when you try to do the TDD cycle, all you encounter is pain and like no positive feedback. It's just tremendously painful. You try doing things like, oh, it's not amenable to testing, so I'm going to start mocking things. And you just mock out everything, and your tests are like gargantuan, and you spend like so much time with this, and then they're completely fragile. And you don't see like, why is everybody raving about test-driven development? Okay, so I imagine if some of you have kind of started this journey, then some of you actually will have had like some pain, and you might have like just bailed and said, this is like too painful. I don't see what people are talking about. in terms of test-driven development. It's like so much better without tests. So if you do get to the 100-hour mark, it means that you've actually gotten some positive feedback, and you actually can imagine and see what it means to like work this way. More than that, if you see some of the benefits, you will never want to work without tests, and you'll become what I call the test infected. Okay, they have started and they do not stop. Right? They never want to work without tests. So I'm hoping that I can give you kind of sufficient picture to get you through the first 100 hours, to kind of inspire you with really working through the challenges and the pain, to experiment and try some ideas, to get you the first 100 hours, and then really start your journey towards mastery. Okay. So let's look at a picture of what it means to program. So for probably the vast majority of the world, this is the only kind of picture of what it means to program, which is just write the code. Okay. And what we're saying is test-driven development gives us a little bit more of a structure than that. And this write test, write code, refactor, that's our TDD cycle, our red-green refactor, right? So we write the test, okay? Before we write the feature, we write the test to see it fail. And then we write the code, see it green. So it's the red-green. This is the second step. And then refactor, which means we improve the code, okay? Now, before we continue, okay, let's talk about, one of the things I said was I'm not going to dive too deep into extreme programming in my last presentation, right? But we're going to spend a little time talking about extreme programming here. So extreme programming has 4 technical practices: test-driven development, simple design, refactoring, and pair programming. And what Kent Beck said is that these practices reinforce each other, and they're much weaker if you pull out any one of them. Okay, so I want to explain why that is. So test-driven development, this is our goal. It's a process of working. Okay, and this process of working is actually necessary for pair programming to be effective. You cannot, pair programming is actually really challenging, and one of the biggest challenges for pair programming is being in sync with your pair. And how are you able to be in sync with a pair? You need sufficient structure. You need a process so that the pair always knows at this present point in time, what are we doing? Okay. If they're out of sync, then it's just not effective pair programming. It devolves into passive navigator who's just kind of observing, and a driver. And that's not what pair programming is like. Pair programming, if you see it, it's like extremely active. It's like constant communication. So test-driven development provides like sufficient structure. Refactoring is one of the 3 steps in test-driven development. And the thing about refactoring is if you just skip it, because you could say, oh, I'm just doing test-driven development. And if people aren't sensitive to like refactoring, then you're just heading towards design dead core. And you can be doing all the practices, like you're doing all of Agile. So you're releasing iterations, you're constantly releasing features, but you're just going to notice that everything just gets slower, right? The velocity of the team just gets slower as time passes. So you have to spend sufficient time. And I would say like the big kind of distinction between veteran TDD developers and kind of more novice is how much time the veterans spend refactoring. So novices will spend just like less time, and veterans will spend like more time refactoring. Now, simple design. So refactoring, you can't like refactoring. For instance, renaming a method. Renaming a method is like changing the name of a method, right? You're not changing, in all of the refactoring, you're not changing any behavior. So, and the refactoring, like for instance, inline method or extract method, they're the opposite of each other. So it's not like, oh, each of these refactorings, if you apply them, automatically you get better code. So it means you need some criteria in which to evaluate your modifications, your changes, your attempts to improve the code. So you have to be able to, simple design is all about evaluation. How can you actually assess whether your changes are good and whether your code is healthy? So Kent Beck said, simple design breaks down into 4 things, okay? It passes its tests, it minimizes duplication, you maximize clarity, and you have fewer elements. Now, JB Rainsberger has kind of gone over these 4, and he goes, okay, passes all tests, that's like redundant. Like, obviously, we're always going to want like green, so we don't need to bother saying that, okay? This one like has fewer elements. He said that kind of principle has never actually like motivated any behavior change for him. So what he says, it really boils down to like minimize duplication and maximize clarity. But he goes, maximize clarity. What does that actually mean, right? For people, it's not prescriptive enough. So what he says is, okay, improve names. All right. So for him, simple design is simply minimize duplication and improve names. Now you can see I've crossed off like all 4 of these things, and 3 of them are motivated by JB Rainsberger. Now I've crossed out minimize duplication. Now Sandy Metz says duplication is far cheaper than the wrong abstraction. So I need to spend a little bit time of talking about duplication. Duplication is it's the easiest thing to detect in code. You can just see 2 things are alike, right? They're identical. And it's very easy to address duplication. You extract, right? You figure out how to extract a constant, a method, a class, whatever is necessary to kind of like eliminate that duplication. And because it's so easy, it's very easy for that to be like the dominant driving force for change. And what Sandy Metz says is like, if that is your dominant force, like that's motivating you, you can actually have like a very unhealthy code base, because there's much more important principles in terms of assessing design than duplication. And if you just blindly eliminate duplication, and you can see this, for instance, if you extract a method because you see duplication, but you can't quite name the method, or the method name is just kind of a repetition of the steps in the implementation of that method. It means, oh, you don't really have you don't have a good name. It means you don't have a good abstraction. Okay. So for me, simple design boils down to 2 things: good abstractions and improving names. All right. So let's go back to we're going to go back to our cycle here, okay? So we write the test first, then we get it to pass, then we refactor the code. Now, is that sufficient for getting us through our first 100 hours? It's not sufficient. For people who've never written a test, they don't know what it means to write a test. They don't know what a test looks like, okay? So what we do is we give them, we tell people AAA. Okay, so AAA stands for arrange, act, assert. So you're going to arrange the objects that you need. You're going to set them up and instantiate them, provide them sufficient data so you can bring them to life. And then you're going to act. You're going to invoke the method that's under test. Okay, and then you're going to acquire the result. And then you're going to make an assertion on that result. You're going to look at what are the side effects, the public side effects. And the trick novices. And so, you know, what we'll do in introducing somebody to TDD is we'll just write pseudocode, arrange, act, assert. You just put that in comments so people realize, okay, I got to fill out these things. And then the trick is you do them in reverse. You start with your assertion. What is it that you're trying to assert? And you code by magic. And what that means is imagine that the object has already been instantiated. Okay, what would be the variable be called if it was instantiated? If it's work order, then you just type, you know, work underscore order, and you write your expectation. And then what you do is you actually invoke the method under test. And then lastly, what you do is you set up the objects that you need. Okay, so the objects might be the object actually under test, or it might be the objects that you're passing in that are necessary to instantiate your object under test. So we'll come back to transformation priority premise. Now, for write code is essentially you do the simplest possible thing to get the test to pass. If people start writing in their head, they're like, oh, I can already see like a full implementation, and they start thinking ahead and filling it in. What you want to be is like the simplest possible thing that will actually get you to green. Okay, sometimes called like shameless green. All right, so that might be like just hard coding a literal value. You just return, you know, if the test is like the test case, all it needs is like a 10 to be returned. You don't actually calculate, you just hard coded a 10, right? And then you refactor. Now, refactor breaks into its own kind of cycle. Okay, so refactor has these like four steps. All right, where and so let me just talk about the word refactor. So refactoring comes from a book written by Martin Fowler, and that book is so here's the second edition. This is what it looks like. Okay, and this book says improving the design of existing code. And I'm so sad about the title of this book, because when people hear the book refactoring and if they're working in RubyMine and it's got refactoring tools, they're like, oh, I have automated refactoring in my IDE. So I can extract a method, I can extract a class, I can rename a method, I have automated tools. So there's no reason for me to like read this book. This book is incredibly valuable because it's actually the foundational book about design. This book is not about refactoring. The most valuable part of this book is actually, it describes all of the code smells. So all the ways to detect code that needs improvement, and then it maps them to refactorings. So refactoring, you can just see by the quantity of like ideas here. You know, people might think like, oh, where the skill comes into play is like in writing code, or, you know, writing tests. And there is skill. There's absolutely skill at play in those activities. But refactoring code, this is where actually there's a tremendous amount to learn. And so what's the cycle for refactoring looks like? Well, you have to identify code smells. You look at your code and you identify them. Then you identify some candidate, like a candidate refactoring. You're going to identify multiple candidate refactorings, and then you have to pick one. You're going to apply the refactoring, and then you're going to evaluate and assess. So I need to talk a little bit more about the word refactoring. So refactoring is two things. Okay, it is both a noun and it is a verb. So those are the two things, right? So as a noun, a refactoring is the activity of changing code where you do not change any of its behavior. So there's no outward facing change to behavior. You're not changing anything that the customer can detect. What you're doing is you're improving the design or the structure of the code. Now, what does that mean? Like, why would we bother doing it, you know, refactoring? Well, it's essentially for readability, right? So the code is more readable and it's more amenable to change. Um, so good design and bad design, it's all about how long does it take for me to actually change my code? How long does it take me to fix a bug? How long does it take me to add a feature? So good design is just the ability to actually keep that time like low, minimize that time. Now that is refactoring the noun, okay? So all of these things here that you can see I've named, mysterious name, duplicated code, large class, long function, all of those are refactorings nouns. Refactoring the verb is going through this 4-step process, okay? Apply the refactoring, all right? That is what refactoring means. It means identifying the code smell, picking a candidate refactoring, and then applying it, and then evaluating. So the act of refactoring is moving through this cycle, okay? That's what that verb means. So, let's look at some of these code smells, all right? So mysterious name. So if you just have something confusing that you don't understand, it's a constant, a parameter name, a block name, then you can rename them. All right. Now, I put a lot of energy here into talking about the moves and principles that you can use for renaming, and I want to expand a little bit on this. So renaming, it's very easy for programmers to kind of neglect the names because you've passed all of the tests. Who cares if the variable is called A or if it's called work order? Like, it's irrelevant. The computer understands, and all the tests are green, and you're done. Like, anything else is a waste of time. And I really want to address this because the majority of time that you actually programmers spend, and there's research on this, the majority of time that you will actually spend as a programmer, it's not writing code. The majority of the time you actually spend is debugging code. Now, if you put aside debugging code, what's like dominates after that? The majority of time is still spent reviewing code, okay, reading code. Writing code is a third. So debugging code, when you're debugging, you're actually trying to understand what's happening. Okay, you're navigating code, trying to understand it. You're not writing code. So the vast majority of your time as a developer, if you are a professional programmer, you are not going to be writing code. You're going to be reading. And so code, we do not write code for the machine. We write code for the reality, our reality, which is we have to navigate this code. Okay. And so the bar for writing code is not that the computer can like compile it and execute it and can pass the test. That is not the bar. The bar is writing, English writing. Okay. So when we read books, there is a high standard of writing that we expect from like contemporary books. We expect not just like wording, we expect that the writer has like a high level of skill, that they're going to incorporate like narrative. If they're expressing ideas, they're actually going to share like narrative to communicate those ideas. That they're breaking down their ideas and communicating them very effectively. So, when they introduce ideas, they're like, they frame it like, why is this important? And then their word choice is like optimal for clarity, right? So they're consistent in how they use words. We don't expect we expect very, very high bar for the books that we read. And even I would say like just written communication. If we were sending out an email or slacking somebody, we expect a fairly like reasonable bar for people in how they communicate with written English. And that bar, I would say you do not want to lower that bar for programming. So in the same way that communication, we invest in communication, and throughout our lives, we never say, oh, I'm kind of comfortable with where I am for written communication. We always seek to improve how we communicate. And it's from everything to the emails that we write, to newsletters, to blog posts, to articles that we write. We're always seeking to improve. And that is exactly the same for software development. You should always be seeking to understand, to express yourself more clearly. So what are some ideas that can help here? You want to reveal intention, not implementation. So Sandy Metz has a good a book called 99 Bottles. And this one book just explores one problem, which is the song 99 Bottles of Beer, right? 99 bottles of beer on the wall. You know, one comes down and then we get like 98, and then it just kind of keeps repeating. And how do you write a program to generate that? And what she shows is you can start off and you can get all the tests to pass, and you can have a method called verses, which takes two parameters, 99, and the second parameter is 0. So you want to start at 99 bottles and go down to 0. And she says that's actually kind of just revealing the implementation of, like, you have these series of verses and it starts at 99. But what's the intention, right? And she goes, it's worthwhile to create a method. It's either called lyrics or it's called song, but something that actually communicates the intention, the real intention. And so, you know, similarly, when you do this, you should be thinking of, like, you know, what's your intention, and interrogate the object. This is a very good technique also by Sandy Metz for looking at names. So if your object is work order, is it reasonable to, you know, ask that work order, create a new work block? And it's like, okay, yeah, that sounds reasonable. What about validate the user? It's like, ooh, that's awkward. Like, why is validating the user on my work order? Like, that doesn't sound like a responsibility of my work order, right? So when you see methods, you can actually ask if it makes sense. Ask the object and say, oh yeah, work order, can you validate the user? And he's like, oh man, that does not sound good at all. That tells me that this code actually belongs like somewhere else. It's like even like poorly named in that example, right? But that belongs somewhere else. So that's a good technique. No acronyms. So one time in working in Ops Core, I had some code where I had SC and FG. Okay. Now, those of you familiar with Ops Core, you're going to be like, aha, FG is like finished good, and SC is subcomponent. And the unfortunate thing is SC did not mean subcomponent in that context. It meant something different. Okay. So no short forms, no one-letter names. Use full names within your code. Okay. You might think like, oh, in my context, like I totally understand, and everybody will understand, but just don't aim for maximal clarity. All right. Anytime you introduce an acronym in written writing, the first time you use it, you actually say, well, here's the full form, and then you put in parentheses acronym. There's no practice like that in code, right? So do not use acronyms or short forms. Ubiquitous language. So this is a concept that comes from Eric Evans in domain-driven design. And what this means is use the language that business uses. Aim for ubiquitous language. So how people actually talk about the problem in the problem domain, you want to mirror that language in your solution domain. So don't come up with different names, right? So if everybody's talking and calls them like work orders you don't want to just start calling them something different, like, oh, well, we'll call it a work bucket, right? And then there's this thing about name things at one higher level of abstraction. This is not about classes. Classes this doesn't really apply, but method names. The idea here is, so going back, she's got this example of 99 bottles where she needs to name something that's going to generate like 99 bottles, and it has to generate the bottles and whether it's plural or not. So that function, you can just tie it and say, okay, it's going to return like bottle. So the name, you can put that in the function name. And what she says is you always want to go like one higher level of abstraction. Okay. And she says container is a better name. So for instance, let's say you need to change the implementation. So instead of bottles, you wanted cartons. You wanted cartons because you're going to do milk instead of like bottles of beer. Okay. And if you tie your method names to the particular detail, then you have to sweep and rename all of your method names. Whereas if it's like containers, just like one level of abstraction up, then that's really good. She says unit is kind of too high a level of abstraction. So you don't want to be like 2 levels up. You want to just be like 1 level of abstraction up. Now, we're gonna, so there's a bunch of smells here, okay? Now, duplicated code, I duplicated in here, which is like duplication is far cheaper than running abstraction. Duplicated code is the easiest thing to spot. And so there's actually something created called the rule of 3. And the rule of 3 works like this. The first time you see something duplicated and you think, I'm not going to extract it yet. The second time you see it, you kind of like wince, but you kind of let it through. You don't address it. And then the third time you address the duplication. And you have to understand the motivation for the rule of 3. The rule of 3 is to guard against premature extraction of duplication. Okay. So it's really to guard against like you don't actually know what the abstraction is, and you just kind of blindly are eliminating duplication. And that's Sandi Metz says like far cheaper, duplication is far cheaper than the wrong abstraction. So the rule of 3 is created to guard against that. Now, you have to understand the intent of rule of 3, because sometimes I will use rule of 3 and somebody will say, okay, well, we've got 3 instances, so I call rule of 3. And I'm like, no, I'm calling rule of 3 that we don't do this. Because intent means if we don't see the abstraction, it's actually better to have like 4 instances, 5 instances if we don't have the abstraction yet, okay? And somebody will say, oh, like, look, Chunky, I'm calling rule of 3 on you because we've only got like 2 instances of this, so it's not, we can't extract yet. And I'm like, oh, no, I'm calling rule of 3 to say that we actually do, because rule of 3 is like, it's around, have you detected the abstraction? And if I have duplication, I only have 2 instances of it, but I can see what the abstraction is, then I can extract, okay? So if we're not going to be motivated by like duplicated code, or I don't want you to be chiefly motivated by duplicated code, like what other things do I want? Well, there's large class, where you can extract a function and extract a class. There's long function, you extract a function and a class. Here's one of my favorites, unused code. Just delete the code. Unused code is so expensive to keep around. Like some really bad things happen. One is unused code usually is accompanied with tests. And that means people are maintaining these tests. As you're changing the code and those tests break, somebody's like maintaining that. And the tests just don't tell you, well, don't fix me because you can delete them because the code's like not used, right? So when you detect that this code's unused and you just like leave it, it's very costly. And the other thing that can happen with unused code is it actually becomes more difficult to detect that it's not used. So it can be very costly to have it. So as soon as you see it, delete it. Now, you should notice a pattern here, which is if the refactoring book has like 24 code smells and 61 refactorings. I don't have 61 refactorings, but what you should notice is that there's actually a handful of common refactorings that if you know, you can get like a lot of power. Okay, so you should know the renames and the extracts, okay? So extract function, extract class, extract variable, rename all of those things. You can get a lot of power. The other one I would say is like essential is like inline function. So whenever I come across code and I'm like, it's just confusing, right? I'm like, I don't understand. It's either under designed or over designed. One of the things I'll do is I can just rename methods and extract things, or just inline it. I'll inline classes or inline functions. I just inline everything into like one giant method. And then I start extracting and I can see patterns, right? So it's a very, very powerful technique if you encounter code that you just can't read. Just inline everything. Okay. The takeaway from this is moving through the TDD cycle, the ability to actually identify kind of code smells and the ability to make moves. This is where there's like a lot of skill, and you can, just with knowing a handful of refactorings, you can be able to start like make progress here. You don't have to know all 61 refactorings, right? And the thing about this is, you more valuable, like there's 61 refactorings that are named here. That's not all the refactorings. In fact, some of these here that I put in this list, they're not listed in the refactoring book, okay? So what does that mean? What it means is, the more important than like this list or even like my list, you need to keep a record of the patterns, the smells that you're encountering, and the solutions that you find. Because if you notice them, you're going to tend to, like, if you see it once, you're going to probably see it a second time. So you want to actually like name them and keep a record of them and with the solutions, and then start sharing and socializing those names, right, with the people on your team. So a big part of software development is just language, right? Being able to very efficiently share ideas and solutions with your team. Okay, so let's go back here. I've said to avoid design dead core, we need to have sufficient skill to be able to perform and execute extreme programming. And I said that XP has a set of technical practices that if we gain sufficient fluency with, then we're going to be able to kind of deliver software at a sustainable pace, right? Indefinitely. So I said all of these things were related, right? So test-driven development is a sufficient prescription for the pair to be able to pair effectively. Refactoring is really the key way that we make software development sustainable and avoid design dead core, because we can keep the code always amenable to change. And simple design boils down to being able to have a strong sense of, developing one skill of being able to identify smells, excuse me, and improving names, and really looking at software development as writing, no different from any other English writing. Now, one thing I didn't say here was, I said test-driven development is necessary for pair programming to work effectively. But why do I need pair programming? And the reason I need pair programming is there's too much to learn, and there's too much discipline required around this to be effective. Okay, pair programming, I said this in last week, but it bears worth repeating. If you care about learning, and for TDD, there's a tremendous amount to learn. If you care about learning, pair programming will dominate any other activity for learning. So if you're going to conferences, if you're reading, you're doing code katas, all of those things are good, and none of them will come close to the rate of learning as pair programming. So if you're a software developer, you really want to figure out how soon can I get into a situation where I'm pairing. If you're not pairing every day, how can you be pairing like once a week, right? Um, okay, so to be able to do TDD, to write a test, you need to have a little bit of a structure, understand how to write the test, and then you write the code, and then you refactor. Now, refactoring it is building up a repertoire of patterns, named patterns of you can detect that this code can be improved, and then mapping them to a map of candidate refactorings. So this list is in no way authoritative. Okay, and even like don't accept refactoring. Like start to make your own list. Now, once you identify and you pick a candidate refactoring, you apply it. Now, this actually is there's only one line here, but there's a tremendous level of skill. So the principle is baby steps. What you want to do is you want to be able to change one line at a time in between running the tests. So you change a line and then you run the test and you see it green. Okay, so that's the ideal. All right. How do you do that effectively? There's a lot of kind of concrete examples in Sandy Metz's book, 99 Bottles. So establish in this practice. So the thing about baby steps is you may not always work in baby steps, but you know how to actually, if you encounter a challenge or you're trying to remain like really in sync with your pair, you know how you have the ability to drop down into baby steps and like work in this manner. And there's a huge skill here. But if you don't have that ability, then it's not an option for you. And it's very easy for you to kind of like fall out of sync or just not work efficiently where you're red for huge portions of time. And then, you either like have to toss code or you're out of sync and it takes you like a long time to get back to green, right? So you want to figure out how to gain competency here in this step of apply refactoring and doing baby steps. Now evaluate. Okay, evaluate is the ability to say, did my change actually improve the code? Am I happier with this change? And the thing about evaluate is it's a judgment, and you actually will sometimes, very frequently, you'll say, oh no, that didn't actually improve things, and you toss your change. Okay, so don't think like every change is good. I actually have this rule of this kind of principle, which is if it's a wash, I toss it. So I go, is the pros or cons? Is it like kind of unclear whether this is an improvement? I just kind of toss it. Horizontal refactoring. This is a very important principle. So with this, there's two things about horizontal refactoring. Okay, and this comes from Sandy Metz and Katrina Owens. And the idea is when you're refactoring, do not start a second refactoring while you're working on the first one. Okay, so it's very easy to see, oh, I can make this improvement as well, right? So don't do that. And the second kind of idea of horizontal refactoring is you want to propagate your refactoring to completion before you start something new. So if you say, oh, you know what? I just have I see what the real names are in this class. Okay, it's a reporting class and I see the names, so I'm going to improve in them. Well, if you have 4 other reporting classes, you want to make sure that you propagate that change to those other 4 classes first before doing something else. Okay, so you establish a context and you make sure that that change propagates throughout that context, because essentially what you want to avoid is the situation where like, oh, I know how to improve on this. And you do this locally, it's elegant, okay? But you no longer have consistency throughout your app. And that's a real challenge, because what'll happen is if that just propagates, and inconsistency will kind of tend to propagate over time if you don't address it quickly, then people don't know what's exemplary. They're like, which one should I be following? I don't actually have a template, right? So it's only in somebody's head that, oh, this is actually the target, and these other ones are kind of historical. Okay, so you don't want to actually rely on that. You want to complete your refactoring, propagate it to all the places where it applies. I worked with one developer, Jason Smith. Everybody called him Smithy because, too many Jasons, right? That's why everybody calls me Chunky. Anyways, so Smithy, he had this thing where he was really obsessed with consistency, and it was wonderful working in his code base. And he did things that would like frustrate me. So I said, oh, like Smithy, could we like use our spec? And he's like, yeah, that's fine, as long as you change all of the tests. And he wasn't kind of being a prick about it. He wasn't saying like no. He actually, if I cared enough to change all of the tests, he didn't mind, right? But his mindset was really it was very kind of mature thinking, because he knew there's certain things where it's like there's not too much at stake and you just want things to be like very consistent. And after working with like, kind of his code base and working with him and on his team, it's very painful working in code bases that just don't have this mindset of kind of valuing consistency. And it's just much slower because you're just constantly saying, oh, like I see this inconsistency, which one should I follow? Solid. Okay, so this is the main thing about in terms of like duplication, so easy to follow. What else should I be following other than duplication? So solid is this acronym that's come up from Bob Martin in Clean Code. Okay, Clean Code is the book to read. It kind of introduces this, isn't it? And all it is a set of principles. Okay, I need to zoom in here. You guys probably can't see this. Solid is a set of principles for doing object-oriented programming. All right, so this is how do you do object-oriented programming? I'm not going to go through all of these, okay? But single responsibility, you can apply this at a function level or class level and say, what is my coherent responsibility? And this is easy, like just use English and ask, right? Interrogate the object as if it exists, right? Say, instance of like work order, what is your responsibility? And when I look at this class and if I articulate its responsibility and I see, ooh, there's a bunch of methods that just don't fall under what I just said is the responsibility. That's telling you that there's multiple responsibilities that have been implemented and contained in this class. So that says, ooh, I can extract. There's a candidate for extraction here, okay? If you are working with Ruby and you want to understand object-oriented design and you want to understand the solid principles, Clean Code is not the best place to start. The best place to start is with practical object-oriented design in Ruby. Okay, so Sandy Metz has very clearly and completely documented how to do object-oriented design in Ruby, and she outlines all of the solid principles. And here's how you do them. So here's how to think about classes, modules, duck typing, inheritance, and composition. So she explains all of these things. Okay, she explains, inheritance inheritance expresses the is-a relationship. Modules expresses the behaves likes relationship. And composition expresses has a relationship. So this is really good. And if you just read the first chapter, like the first couple of chapters, I'm really sad because what she does is she introduces inheritance. And then in subsequent chapters, she just says, okay, here's the better alternatives. Okay. But if you just read the first couple of chapters and she explains how to do it well, like if you're going to do inheritance, here's how to do it in Ruby, right? If you're going to create a module, here's how to do it in Ruby. But if you just stop there, you will not see the better alternatives. And if you go all the way and you skip the last chapter where she explains kind of like how to do this, what the impact is for testing, how to test effectively, like all these things, like, I'll be very sad. So it's a very, very good book. Highly recommend it. Now, So that's like solid. Composed method is an idea introduced by Kent Beck. You want small methods, and your method should speak at, they should communicate and express themselves at a consistent level of abstraction, and they should be declarative. So if I see like a top level method's like really long, and there's a consistent level of abstraction, one way to think about it, this is a kind of a squint test. You squint and you just look to see the color and the shape. And if you see, ooh, I got like a bunch of strings and constants, and I'm making like a lot of method calls at a lower level API, so there's like, some SQL mixed in there, then I don't have like consistent level of abstraction. So I want to name things and extract. And it should be declarative. Your top level method should always be kind of short and declarative. That's what you should aim for, composed method. Prefer composition to inheritance. And flocking rules. Flocking rules is a powerful notion that's introduced by 99 bottles of OOP. And what this says is, how can you be driven by inconsistency? How can you drive your development by like noticing inconsistency? And so the flocking rules are very simple. What you do is you select the things that are most alike. You find the smallest difference between them, and then you make the simplest change that will remove that difference. For me, flocking rules didn't make sense until I actually like saw examples, and this is very powerful. These things are explained by Katrina Owens and Sandy Metz in 99 Bottles of OOP. Okay, so duplication is easy to spot, and there's like alternatives to drive how you improve your code. Okay. All right, so this is the cycle. When I say refactoring as a verb, this is refactoring as the verb. All right, how you improve here is you start keeping a journal of smells in code, choose a name for those smells, and choose like candidate refactorings, and read the refactoring book. Okay, there's 24 named code smells in there. So if you are using those smells on your team and you have consistent language, you will be much more effective, right? You can communicate extremely tersely and say, oh yeah, this is like feature envy. And your pair says, oh yeah, it's totally feature envy. What are our options for feature envy, right? So that is refactoring code. Now those three steps are the kind of TDD cycle as we kind of traditional TDD cycle. Red, green, refactor. Now is that sufficient? This might be. I've like unpacked. I like packed in a lot, and this may be sufficient for getting you through the first 100 hours. Okay, but it turns out there's like a lot of things that can be very painful and kind of catch you. One thing that can catch you is refactoring tests is distinct from refactoring code. A lot of the smells and patterns that apply to refactoring code also apply to tests, but it turns out tests have their own distinct patterns and smells, and then ways to address them. So there's this book, X Unit Test Patterns. It lists like 15 test smells and 68 test patterns. If you ever want to know like what's the difference between a fake versus a double versus a mock versus a spy versus a stub, like this book will explain to you what those differences are. Okay, so it is named the test smells, and it's named many test patterns to kind of like address these things. And this book didn't kind of invent these names. It actually just extracted the existing vocabulary from the community. So these names still persist. All right, this is a very, very good book for understanding the language of tests. Let's look at some of these things. So this one is great, right? Test method name says what. So it's actually just kind of a description of the contents of the test method. It doesn't say the why. What's the intention? And something, another way of like stating this is just like, oh, the test intent is like unclear. So just like improve the test description. This one's good. Irrelevant information. So is your test method, and this, you could also see this with like long test method, right? But does your test method have like a whole bunch of detail that's not relevant to your expectation, right? So is there a whole bunch of like, is half your test method just like setup? Well, you can like extract, creation methods, right? Extract helper methods. So you want to hide the things that are irrelevant, so the test just reveals what's necessary and important for the expectation. Understand RSpec. If you know your tool, use have attributes when you're doing when you're placing expectations. So I would actually say XUnit test patterns is very well worth reading. It's really good. But something that you want to actually read before this, if you're really interested in developing like a kind of fluency and competency with tests, is there's a book called this one, Effective Testing with RSpec 3. That's like very good. I recommend that, right? So that's that, we use RSpec here. So there's one page in this book in the appendix where it just has a bunch of the built-in matchers for RSpec. That's really valuable. You can just print it out and you'll probably like, you'll reference that thing like daily if you're working with tests. So the key to understand here, the thing I haven't explained is that, how much time are you going to be spending with tests? If you're doing TDD, about half your time will be spent in tests, right? So half the time you're like writing code and half the time you're writing tests. And that's not a bad thing. That's a very, very good thing. You're in the long run, you are much more productive in cranking out features if you're spending half your time writing tests. Now that sounds like a lot. Now it's very easy if you gain competency with identifying smells and applying refactoring with code to neglect tests and treat tests as like kind of a second-class citizen. You do not want that to happen, all right? Because what ends up happening is you have this weird thing like, if you're unable to kind of, if you're not going through refactoring and you're keeping your design clean, then you get design dead core. Now, something very similar happens if you neglect your tests. What ends up happening is the tests become a barrier to change. And you can't actually add your feature because the impacts to your tests are too costly. You're like, okay, this feature might be valuable and it's not valuable enough that it's worth the effort to kind of like change all these things. And that I've seen that happen. So what that means is gaining fluency in terms of applying, detecting code smells and applying appropriate refactorings. Tests have their own distinct patterns and you need to also invest fluency here, okay? And same thing applies. You need to keep your own record of the things that you're detecting. If you see it once, you're gonna see it a second time, and then responses. So you're gonna go through the exact same cycle here. Identify code smells for the test, identify candidate refactoring, apply the refactoring, and then evaluate. So at this point, what's left? Let's look at kind of like some common mistakes. Okay. Oh, actually, before we get to that, that covers like write test, write code, refactor test. Okay. So what about legacy code, legacy code is basically you find code that is not under test. All right. So when you find a code that's not under test, you actually have to do some refactoring just to be able to like write your first test. Okay. So it's called creating a scene. Okay. You're trying to look for a point in which your test can be written against. Okay. So this is talked about like by Michael Feathers, and his book Working Effectively with Legacy Code is really talking about creating a scene. And there's 4 things you can do. Okay. So you can sprout a method, which means on this class, you create a whole new method, and then that method is kind of separate. It's going to be called somewhere by your code, but you can like start writing tests against that method. Now, sometimes you can't do this because bringing the class to life, like instantiating the object, is just too complex, right? There's no test for this class, right? And it's not written to be testable. And so bringing the class to life might be too complex. So what you have to do is you have to sprout you have to create an entire new class that you can put under test. And then you can instantiate that from where you need to in your code. Now, sometimes what you need to do is you need to like modify like an existing method. You can't really do an extract method. You're trying to change the behavior, but you don't really want to change that method, right? The method's too big, it's too complex. And it might be called from like multiple contexts. So what you want to do here instead is you want to like wrap that method. Okay. So you're not going to change the existing method. You're going to wrap the method, and then you're going to place that wrapped method under test. Similarly, like the wrap class is kind of corresponds to your sprout class. So that's what you need to do if you're working with legacy code. So that's the TDD cycle. Now let's talk about some common mistakes. Okay, a big common mistake is treating code as if it's the only thing that matters. And so people might care about like improving names of classes, but if you treat code as if it's the only thing that matters, code, we write code to communicate, but it's not the only way we can communicate what's important. All right. So lack of documentation is a common mistake. So I want people to be very sensitive. There's a very easy trigger that will trigger you to like write documentation. And it's this: if somebody asks you the same question like twice, okay? So if you get asked the same question twice, it's like, hey, how do you do this? And the first time, fine, you just tell the answer. The second time somebody says, oh, how do you do this, right? How do you update the permissions on auth to 0? It's like, oh man, it took us like 2 hours to figure that out. And it's like the second time, it took us an hour to figure it out, but like I've totally forgotten. And now I have to like figure it out again, right? So the second time you get asked a question, that should trigger you to document. And after a while, you won't need that trigger, because you're going to do something called documentation first development. And documentation first development says this: you realize there's like inadequate documentation. And what you do is, instead of just doing the right thing, as you figure it out, you write the documentation first before you actually take the step and do it. Okay. Lack of comments. So sometimes we will have access to information. We will know it, and then we will lose it. Okay. And it's not captured in the code. So for instance, we spent like half an hour figuring out that we needed to downgrade a gem. And we found multiple threads, but we found the thread that explained why we needed to downgrade the gem, because it's incompatible with this other thing. But when like the next kind of like minor version update should like fix it. Okay. So if you just downgrade the gem and you just commit it, you've lost that knowledge, right? What you could do is you could put a comment in the code that says, this is why like I downgraded this. And like at the very next like minor version upgrade, this should be updated. And you could put it inside the code commit, but we have a tendency to treat code as the only thing that we should do, and that all comments are bad. Okay, and I believe that everywhere I've seen, there's a tendency not to like avoid comments, and what it means is like we just under comment. Okay, so if you spent any time capturing something like very important, and you know like we're going to need to look at that again, like that knowledge is going to be useful, like put it into the code. Okay, this is an interesting one. So in TDD cycle, it's very easy to just think about this as like, okay, this is what I do when I write features. When you write a bug, this applies as well. So not when you write a bug, when you're fixing a bug, this applies. All right, write the test first before you actually fix it. Premature performance optimization. So if you're continuously kind of like thinking about optimization, I want you to think about kind of change your mindset. I want you to think about readability first, because performance optimization, you make moves to the code that's less readable. So start with readability first. First, make the code as readable as you can, and then there's techniques that you can use to like optimize the code. So in Ruby, you can memoize methods. It's a very effective technique for focusing on readability first and then doing performance optimization. Right? If you don't know how to memoize in Ruby, Google Ruby like memoization, and the first thing you find will totally explain the options for like memoizing in Ruby, how to do it. Yeah, so we write for, we read code most of the time, not writing. So don't optimize for writing code. Some people will say like, oh, I'm going to choose like terse method names because they're shorter to write. No, we need to optimize for readability first. Oh, I'm gonna skip this mixing the API change. Only refactor after adding a new feature. So Kent Beck has this statement. I gotta blow this up so make sure everyone can see this one. So Kent Beck says, first make the change easy, warning, this might be hard, then make the easy change. So what does that mean? What that means is if we're adding a feature, okay, we might think, okay, first I'm gonna like write this test for this feature. And Kent Beck is saying, no, first think about this, okay? Look at your design and see how's the code structured, and could we change the structure of the code to be able to add this feature in so that it's very easy to add. What would the code need to look like? And he's like, don't bother adding the feature first. First, change the structure, refactor, change the design, and then add in the code. All right. So this thinking is like, it's not really in the TDD cycle, right? And what this is like refactoring might not be your fourth step, right? It might be like your first step. Like you need to assess, is it going to be easy to make this change? And if not, could I change the structure of the code first? And then you do that. And I've talked about this one already. So I've outlined what I hope is going to be sufficient structure for you to get through the first 100 hours, okay? But I need to talk about, go back to mastery. So we're talking about mastery. Now, the thing about 10,000 hours is it's not just like putting in time. So think about somebody who is a professional race car driver and somebody who commutes to work. So commuting to work, you might be putting in tremendous amount of time. If you're doing an hour on the highway each way, you're putting in a tremendous amount of time. But are you a master? Are you an expert driver? And the answer is no, because the 10,000 hours is not just putting in time; it's deliberate practice. So race car driver, like that's deliberate practice, right? So what's deliberate practice look like? I took a car control school, and when I did car control school, so this is when I was like learning to drive. I did like young drivers, and I did like car control school. And car control school is interesting because it's not required for like getting your license. And the people who actually take car control school are people who are like racing recreationally, right? So they'll go through like obstacle courses, or they'll just go through racetracks, and they'll like recreational racing. And that's people who are interested in car control school. But car control school, it should be mandatory for everyone, because what they teach you in car control school is not how to move fast. What they do is they teach you safety, right? They teach you how to have control of your car and to move safely in like unexpected or rare situations. Okay, so what do they do? What they do is they put a bunch of pylons, and they put the instructor sitting with you, and you drive at a fairly good clip towards these pylons, and then the instructor tells you to turn left or right. Okay, but he does it so you have very little time. And the same thing happens every single time. They explain to you how all of this works in class, and you're like, oh yeah, I totally get the theory. I get it. And it's going to be very easy to do. But when you're actually, he goes left, and the same thing happens every single time, which is your just instinct. Your instinct is to hit the brake pedal, and then you just plow, and then you try to turn. And the thing is once your wheels are no longer turning, you have no ability to like change direction, right? It's just the momentum of your, once your wheels are not turning, you're just sliding. So it doesn't matter what orientation your wheels have, your tires have, you're just sliding on the ground. So it doesn't matter whether you turn the wheel, right? Your tires change orientation, you're still just sliding based on the momentum of the weight of your vehicle. So I just plow through these pylons, and it's the same for everybody, right? And what they do, they keep doing this until you override your instincts, and you're able to actually do the correct thing, which is you hit the brakes, and you just like pump the brakes. You hit the brakes, you pull off, and then you do this weird thing where you like you just turn the wheel, you jerk the wheel, and you go back straight. Because if you jerk the wheel, you just like go off into like if you're on the highway and this is happening, you'll go off into the rails, or you'll just start careening into cars like 3 lanes over, right? So you just jerk the wheel so you can move around, and that now you're in the other lane, right? You're off shoulder, you're in the other lane, and then you pump the brakes. So it's totally counterintuitive, and they just keep doing this until you get fluency. Okay, so that's what deliberate practice looks like. So so deliberate practice. Let's zoom into deliberate practice. Deliberate practice, and this is explained by in Grit, Angela Duckworth explains deliberate practice. So you have to have a specific goal, right? What are you trying to improve? You pick something that you want to improve. For car control school, it was how do you stop suddenly and be able to move around the thing that's like right in front of you and stop suddenly. The other thing they teach you is when you're skidding, how do you actually come out of a skid safely? And that's another like very unintuitive skill. So pick a specific goal. And so that goal is going to drive what you're actually going to do. And you're going to do something that requires your full attention. What does that mean? It means it's totally outside of your comfort zone. It means you do not have competency. It means it's going to be very effortful and awkward, and you're going to do poorly at it. Right? And then you get feedback. Feedback comes in two forms, right? Either you have like an expert who can just candidly um, tell you what they see and where you can improve and correct. And then, or you measure, right? You take measurements, you figure out what, for this specific goal, what's the relevant like measure? So your goal might be, for instance, like, I want to learn the, all the keyboard shortcuts for my IDE. So what you might count is, how many keystrokes does it take me to complete this code kata? And then you look and you measure and you see, ooh, how can I shave off like another 5 keystrokes off of this, right? And then you reflect, you look at your performance and you assess it. And you say, here's where I improved, and here's where there's still like room for improvement. And then you iterate. So deliberate practice is something you do every day, right? That's what like makes mastery. So the thing about this is, some of these ideas and learning these things, I want you to get through the first 100 hours. I want you to be test infected, and I want you to achieve mastery. Software development is a field where we do not have, you could go to piano and there's a long history of instruction, of teachers, of, levels of, here's like specific ways to teach specific skills at these level. And then people devote the time. They realize like, oh yeah, if I want to move up these levels, I need to devote time and mastery. I need to devote time for deliberate practice and improve my skills. We do not have, software development is like a much kind of younger field of practice. And I would say is like no less demanding in terms of mastery. So you could just rely on like your day-to-day work. But that's not deliberate practice, which means there's a big difference between just daily commuting and your ability to drive, and then like a race car driver who's doing deliberate practice, right? So I want people to become race car drivers. So I'm going to say a little bit more about deliberate practice. So Angela Duckworth, how she got interested in this whole topic of deliberate practice, she watched this documentary called Spellbound, which is really interesting. It's a documentary. It just follows some kids who are trying to win the spelling bee, right? And it follows some of like very kind of expert spelling bee competitors, and just tracks them and sees how they're doing. So she got in touch with like, the person who made the documentary. She got in touch with these kids, and she got in touch with a whole bunch of people, and she started to like, she asked some interesting questions of these people and started collecting data. And what she asked was, what kind of things do you do? And so there's 3 for spelling bees. There's like 3 things. You either get quizzed, so you can get quizzed by like your parent. You can do, you can like, study words, and you can just read. And studying words was the most demanding. On average, like that's what people deem the least pleasurable, okay? It's like the most demanding is like studying words. All of these 3 skills are important, but that is the one that kind of equates most with like deliberate practice. It's just like you're plowing through the dictionary and studying words, right? And what was interesting is there was a difference between novice, like rookie spelling bee competitors, and the veterans. And the difference is that the veterans got more pleasure from that form of like that deliberate practice, and then the rookies, like, you know, it was very painful for them. Now, Angela Duckworth says there's two possible interpretations. There's two reasons why this could be the case, right? One reason is because people who get more pleasure out of doing the deliberate practice, it's kind of self-selecting. They're the ones who stick with it, and the ones who don't get pleasure, they fall out. They fall off of it, right? And that certainly, you know, has to be true, right? But the second thing she says is interesting is the people who end up spending time, in some ways, they figure out how to love the burn. They figure out how to love it. They figure out how to reinterpret their experience as progress, that they're making progress. So they can see like the pain actually gives them like a form of pleasure, right? So the thing about that is your brain is highly susceptible to framing, okay? Which means you can use that to your advantage. You can figure out how to reframe experiences and your mind will like buy it, okay? So if deliberate practice is something that's painful for you, figure out how to frame it, that that is how you're actually like making progress, like learning. And do experiments until you're able to establish that frame, okay? Because people are able to actually reestablish and reframe their experience. So they love the burn. Okay, so that's deliberate practice in general, right? I told you about how to do deliberate practice if you want to figure out how to stop suddenly and like avoid something that stops suddenly in front of you. But what does deliberate practice mean if you want to become like test infected? Okay. There are code katas. Code katas. I'll send out a link to this later, but there are code katas. Gilded Roses is like a very famous one. Medicine Clash. This teaches you how, like, if you have a bunch of like one-line methods that have been extracted, you know, how do you figure out, and it's like completely unnecessary, how do you figure out that code and simplify it? So this is like where like inline method becomes like very valuable. There's a bunch of like katas that you could do. And if you just Google like code kata, you'll find like many code katas you can work on. So what's a code kata? Kata comes from like martial arts. And what it means is you do a series of movements repetitively until it becomes unconscious. So you don't actually have to think about the move. You don't have to think about the kick or the punch or the block, right? It just becomes like reflex. And so in the code kata, what you do is you solve a coding problem and it feels awkward and you keep doing it repetitively. Now, the point of the coding kata is not that you're just kind of solving, you pick what you want to learn. So you can do the Gilded Rose over and over again, and you might be comfortable, but then you pick something else to learn. So for instance, maybe you want to focus like, you know, on like writing tests. So you want to actually have like very clear tests. Maybe after that, you want to focus on frequent commits. Maybe you want to focus on having clear commit messages. Maybe you want to focus on object-oriented design, all right? So you pick your goal, you pick the thing that you really want to improve, and then you work the kata and you keep doing it until you've gained fluency. And then at some point, it's no longer effortful, and then it's no longer deliberate practice. Then you pick something else. So you can do deliberate practice at work. Okay, how do you do deliberate practice at work? You can do something called intention-driven pairing. All right. So for that day, set an expectation of what it is that you want to focus on. You could say, you know what, I'm very weak at like Git. And so what I want to focus on is I want to actually focus on just upping my Git fluency. So that's what's going to be my like focus for the day. And then you can set expectations for each Pomodoro. Okay. And your expectations for each Pomodoro might be related to your overall goal for the day, or it might not. Okay. You might say, oh, no, the goal for this day is just to get in sync about the work. So our goal is just to have like all the work captured in our backlog in Trello. Okay. But you can set expectations for each Pomodoro. Work in Pomodoros. Okay. Pomodoros is a way of being very intentional with how you use your time. Okay. You work in essentially, 25 minutes focused chunk of work, and then like kind of 5 minutes to a break, a reflect. Now, if you're doing intentional driven pairing, the Pomodoro, you set the expectation and start Pomodoro, what you're doing for that Pomodoro, and then you breathe. You don't have, your break is essentially used for reflection, which is, did we achieve our expectation? How did that Pomodoro go? And how are we going to set up for the next expectation, right? What are we going to try for the next expectation? And then you close the day with a retrospective. The retrospective serves, two purposes. One is you're thinking, what did we learn today? How did it go? Did we meet the expectations? Did I up my competency? Did I get good practice in for kind of like, what I wanted to focus on, which is improving my Git competency. And then and then the second thing is you just set up for success for the next day, meaning, identify, are we going to rotate pairs? Who wants to stay on? And, you make sure to capture everything that you need so that the next day you can like start strong, right? Book clubs. Book clubs are in the same way that pairing, like doing development in pairs, is so much more effective. You can get so much more information out of books if you're actually doing it as like a team, right? I put these three because these are like, these three I consider the fundamentals of software development design. These are the design fundamentals. Yeah, so if you've read those three books, you've established the fundamentals, right? But you can get much more out of books if you like read it as a team. Code smell of the day. So code smell of the day is you can take refactoring, which has the code smells, or clean code, which also lists code smells, and you just pick one randomly. You just pick a smell. You read that definition with your pair at the start of the day, and you just look for opportunities during the day if you come across that smell. It doesn't mean that has to focus your work or you have to fix all of those smells. You just are conscious of, hey, this named concept, can I actually identify it throughout the day? 5 minutes a day. Figure out how deliberate practice is only meaningful if you can actually establish daily practice. So figure out, how can I schedule at the same time every day to do 5 minutes every day? Now, 5 minutes sounds like a ridiculous short amount of time. Your goal is not to really do 5 minutes a day, okay? Your goal is simply that you have established a practice, that you're like, this is what I do. Every time this day, at this point, I am devoted to deliberate practice, all right? So you want to lower the bar for threshold. You don't want to say, oh, I'm going to do 2 hours every day or something ridiculous, right? Even 1 hour, you might end up moving towards an hour, but you don't want to start there. That will actually ensure that you do not. You want to lower minimize the threshold for establishing a practice. So 5 minutes every day, okay? Okay, we are going to take a 5-minute break, and then I'm going to do performance. So I will see you at 11:40. Let me see if I can stop this and start this back up. All right, so let's continue. Now, what I'm going to do is I'm going to do a performance on the Gilded Rose Kata. Now, a performance is not deliberate practice. So deliberate practice is where I'm picking something where I might not have competency, and I'm doing something to improve. Now here, I'm doing a performance. So I've done this a few times, and now I'm going to show you kind of what fluency I've gained with a particular skill. Okay, so we're going to go to Gilded Rose. You can see I've worked on this like 99 times. So we're going to start off the starting point here. This is the 100th time. CD into here, and I say run. So run is a script that's just going to detect any file changes, and it's going to run the tests. Now, Gilded Rose. Let me talk a little bit about Gilded Rose. Not everyone may be familiar with Gilded Rose. So Gilded Rose is it's a tavern in World of Warcraft where we have a set of items that are on for sale. So there's this fantasy world with a set of items. So if we look at this test, here's our set of items. Okay, items have names. They have a sell-in, which is kind of like days till they're expired, and then they have a quality, which is kind of their price. Okay, and my test. This is These are called characterization tests. So these tests do not actually communicate anything about intent. Okay, what they do is they lock in the behavior, the current behavior of the code. So I have an old implementation called Gilded Rose old. Okay, and then I have Gilded Rose, which is a duplicate. So these two things are kind of identical: Gilded Rose and Gilded Rose old. And then my tests build my array of items, and it passes these items to each of them. And then I call update quality, which is essentially it's a method that you run each day for the store to update the days till they're expired and the price. Okay, and then what I do is I just compare. I compare the items for both of these implementations, and if they're the same, I don't complain. I get green. If they're different, then my test will tell me there's a failure. So this is what's called characterization tests. Okay, I'm just testing that the behavior has not changed. Now, what am I going to do here? The thing that I want to demonstrate, or I'm focusing on for this category, because I had to focus on so many things, but I'm going to focus on a refactoring, a particular refactoring called flatten nested conditional. So, so here's my code, and the first thing that I'm going to do before doing anything is I'm just going to make a white space change and save. Now, I have Rubocop kind of auto formatting on save. So you can see like, oh, Rubocop compressed a lot of things, okay, for me. So I'm like, okay, thank you, Rubocop. Now, sometimes I'm like, oh, I actually want to change like item. For those of you who know Gilded Rose, that's really going against the spirit of the kata. But in this case, I'm like, I'm not going to override item. So I'm going to delete that implementation because I'm not playing with item. I'm really going to be like addressing like this code in this method, okay? Now, one thing I want to do is I want an adder reader for items. So I'm going to create the adder reader for items, which allows me to take off this at. Now, anytime you have, like, I have just a simple initialize with a constructor like this and an attribute, I'm like, this is just a struct. So I'm like, I can just do this and I get rid of these things. Now, just like I'm seeing green, okay, but why not get a failure so I'm confident that this is actually, so I'm just gonna put a typo in here. And I see, okay, good. It's giving me, it's saying, hey, when I did this update, this backstage pass, I expected it to be 21, but I got a 19. So it's like not working. So that's good. So I'm confident now that my tests are actually gonna catch any mistakes I make. Now at this point, what I'm gonna do is I want to extract the method, this body for this loop. So I'm going to put it in its own method. I'm going to extract a method. I'm going to call this update item. I don't need private. That's just noise for this exercise. Now, RubyMine was clever, and didn't give me a block. It just used the method and the to-proc to kind of make it more concise. But now this is really where the refactoring starts. Now, flat nested conditional, like I can see, oh man, this is perfect for flat nested conditional, because I can see I have nested conditions and the conditions are really apparent. Okay, the conditions are all around like item name. Okay, so age debris, backstage passes, sulfurous, right? Backstage, sulfurous, age debris, backstage. So there's only like 3 different names here. So there's 3 named conditions, and then there's an else if you're like not one of these 3. So how flat nested conditional works is I just put in, I say item is equal to, I identify all of my conditions and I simply create a block for them. So here's my 3 conditions, and I need an else, and then I gotta put in these names. Okay, so here's my conditions. Now what I do is I just take, I'll save this so Rubocop kind of fixes my indentation for me. But oh, and look, Rubocop's so clever. It's like, oh, you don't need to do that. You can just use case. I'm like, okay, thank you, Rubocop. So I take all of these conditions and I just paste them. Oh, but it got rid of my else. So I want else. So I'm just going to paste this into each branch of my conditions, and I hit save. Rubocop will fix my indentation, and everything passes kind of trivially. But you're like, oh man, Cheong-Kee, that's like so much worse. Like, how is that any better? Well, here's the magic. Okay, the magic is in this branch, I know I have age debris. So does this not age debris apply? No. That does not apply. So I can get rid of this. I can get rid of this branch here, which means I can do this. And I know I'm age debris, so I know backstage pass does not apply. So I can just get rid of that. Here, I know that I'm not sulfurous, so I don't need the condition. This is simply if true, right? Here, not age debris. Well, I know I'm age debris, so this condition doesn't apply, which means I can get rid of this if. Okay, and we're still passing. So wonderful. So age debris. So let's move on to backstage pass. So not age debris, not backstage pass. Well, I'm backstage pass, so this doesn't apply. So I can get rid of this. I am backstage pass, which means I can just get rid of this condition because it's just if true. This is like not sulfurous, which means this is just if true, so I don't need the condition. Not age debris. I am in fact not age debris because I am backstage pass, which means this is true, which means I can just get rid of this guy. And I am backstage pass, which means I don't need the condition, which means this guy applies, and I can just get rid of this. Now sulfurous. All right, sulfurous. So sulfurous is not age debris and not backstage pass. Well, that's true. So I can pull that out and just get rid of this branch. And then this says, oh, and I'm not sulfurous. Well, I am sulfurous, so this whole line doesn't apply. This says not sulfurous. Well, I am sulfurous. This doesn't apply. Not age debris. Well, not age debris applies to me because I'm not sulfurous at this point, so I can get rid of this. And backstage pass, no, I'm sulfurous, so I can get rid of that branch. And I'm not sulfurous. So I'm like, oh, not sulfurous. Well, that doesn't apply to me. And this is empty branch. And then that's nothing. Now, so we've removed the entire body of sulfurous. Now, why is that? Well, sulfurous, if you understand that, it's a magic sword. And it actually, its expiry, it never expires, and its quality, like its price never goes down. So updating the item is like a no-op for this magical sword, sulfurous. Now, let's go on to our else. So I'm not either of these 3 things, okay? So I'm not age debris, not backstage pass, so this is true, and I can get rid of that else. Here I am like not sulfurous, that's just if true. This condition is if true, so I can get rid of it. Not age debris, that certainly holds for me, so I can move that out and then just get rid of this guy. Not backstage, well, that doesn't apply to me. And then not sulfurous, that's just an if true. Okay, great. So that was applying like flat and nested conditional. Okay, so let's proceed. So we're not doing flat nested conditional at this point. At this point, it's like, oh, I noticed this is just increment, right? This is just +1 to quality. So I'm like, I'm just going to change that to increment. This is just decrement. This is just minus equals 1. This is just decrement. This one's interesting. Item quality minus item quality. Well, that's just 0. Okay, good. So the next thing that I notice is let's take a look at aged brie. What's going on here? This says increase the quality if the item quality is less than 50. So what is this doing? This is trying to say, don't go above 50. Well, I can actually do that. I can say item quality. I can apply this constraint, set the item quality to 50 if the item quality exceeds 50. And then I don't have to guard this. Also, that's what this guard's about. I don't have to guard this either. And it turns out there's a similar thing going on here too. So I can apply this guard here, so I don't have to like have this nested guard, and I don't have to guard this 50. And there we go. Now, there's a similar thing here, but here they were increasing quality. Here is about decrementing quality. And it goes, don't decrement if it's like, or only decrement if it's greater than 0. So it's trying to apply a lower bound. It's trying to say 0 is the lowest you can go, right? So I can say, okay, if item quality is less than 0, then make it 0. And then I don't have to actually guard this limit here. Okay, great. Now, the thing about this is like imposing the upper bound, and then this is imposing like respecting the lower bound, right? Well, what happens if I just make them consistent? Okay, what would that look like? Well, if I make them consistent, I would do this. The test will still pass, but I'm like, Cheong-Kee, how's that any better? Like, we just added like number of lines. Well, it's better because I can do this. I can say item quality is equal to item quality, and Ruby's got this nice little method called clamp, which says, hey, please ensure I'm within bounds, right? My lower and upper bound. So I can tersely express my upper and lower bound, right? Get rid of those conditionals. Now at this point, I'm doing two things here. I'm updating quality, and I'm like updating the cell-in. So what I want to do is separate those two things, right? So I'm going to put the cell-in above. That'll pass. I'm going to attempt to put the cell-in above here. This will fail. Now, this fails because cell-in's being used in these conditions here. So if I go above here, this is now 1 less because I've decremented. So I actually have to set this to 5. And then if I go above this guy I have to set to 10. Okay, so now I can put this at the top. Now this guy is easy to put at the top, and that'll pass. Now, what's interesting is I'm going to apply flat and nested conditional again. And you were like, well, Cheong-Kee, there's no nested conditionals. Like, well, yeah, there's no, it doesn't look like there's any indentation, but there's actually, it's going to be easy. This is like a hidden, it's not a nested conditional, but I'm going to still apply this refactoring. So let's see what it looks like. What I want is, I just want an if-else branch, right? I don't want like do this thing and then do this second thing conditionally. So what's that going to look like? Well, flat nested conditional goes identify all your conditions. So my conditions is this condition and an else, right? When that's not true. Then I take the entire code, okay, and then I paste it into both branches. Now this should trivially pass, right? Now I know in this condition that this is true. So this is just if true. So I don't need to do that. Now I know because I'm in, this is the else, that this is not true. So I can just delete this branch. Now I know that this is just 2. Now, Rubocop cleverly realized, oh, it's just duplication, and pulled that out. So at this point, I'm like, this is just best as a one-liner. So I'll make this a ternary, right? Rubocop will just like detect that as a ternary. So same thing applies here. I'm going to apply flat and nested conditional here. So same thing. I'm going to put capture my condition. I have else. I'm going to take everything that updates quality, put it here, save. I'm like, okay, this is just if true, and then this line doesn't apply. This is going to be 2. Rubocop's going to extract the duplication for the assignment or the decrement. And then I just want a ternary. And then that looks good. Okay. So now I'm going to do flat nested conditional. This is a little bit more complicated here for what's happening here with quality, right? But I see I have 3 conditions and an else. Okay. So I'm going to just apply flattened nested conditional. Now, the thing about this, I got rid of my else because there's no body in there, but the thing about this is the wrong order. Okay, these conditions are not in the correct order because this is saying less than 10. Well, I'm never going to get to the less than 5 or less than 0 because the less than 10 guards it. So these are in the wrong order. So I actually have to put this first. This is the order that I want things. So now that I have the correct order, I can take all of this. Let me try it again. I'm going to take all of this and I just post them into every branch. And then I get rid of these guys. Now that should pass. Okay, which it does. So now in here, I'm less than 0. What does that mean? Well, it means I'm less than 10, I'm less than 5, and I'm less than 0. So all of these apply. Now, this last one just trumps the others, so I don't need those. Now, I'm less than 5, so what do I know? I know that I'm less than 10. I know I'm less than 5. I'm not less than 0 because that got caught in this other branch, so this doesn't apply. So in fact, this is just +3, right? Now this one is less than 10, so I know this one applies, and the other 2 don't apply. Save this guy, it passes, and then I go +2. Now this guy, I know I'm not less than 10, 5, or 0 because I would have been caught in all the other branches. So this is just +1. Now here, what I want to do is this is expressed as an upper bound in this condition. Okay, so I'm going to just change this. Okay, I'm going to express a range. So this has to be less than 0. I'm going to arbitrarily, I'm going to say, oh, I'm going to say I have a range from -100 to -1, and does that cover selling? And it does. And then this one is going to be negative. This is going to be 0 to 4, and does that cover my selling? And then this one is going to be 5 to 9, and does that cover selling? Okay, now at this point, Rubocop goes, oh, we can just use case. I'm like, thank you, Rubocop, that's nice. Now, for this else, I'm going to change this. This is basically, this is like when 10 and up, okay? That will pass. Now these guys, I want to put the parentheses around. Now what I want to do here is I'm just going to express these. Now that I have these ranges, now I want them in a different order. Okay. Now I want these in this order. Because before I was really expressing them as upper bounds. Now I want to express them as lower bounds. Okay. Now because this is at the end, I can just say this is my else case. Let's save that. That was a little sloppy, not running my test there, but and that concludes my performance. At this point, so that demonstrates my fluency with flat and nested conditional.